Welcome back, Honors Algebra. So right now you should be looking at your 7.5 Day 2 notes, and we're going to continue on starting with problem G. And if you look in our denominators of the quotient that we have two terms in the denominator for each of these examples. So if you're given two terms in the denominator, you can't just simply get rid of the radical sign. You have to take in consideration both terms. So to rationalize the denominator of these quotients, we actually have to multiply the numerator and denominator by the conjugate of the denominator, which is the same exact denominator except the opposite sign. So the conjugate of 3 minus square root of 3 would be 3 plus the square root of 3. And whatever you do to the denominator, you have to do to the numerator as well. So when we multiply 9 times the quantity, 3 plus the square root of 3, all over, we have to multiply these two, and we're going to get the quantity 3 minus the square root of 3 times the quantity 3 plus the square root of 3. So when we go ahead and simplify, we're going to distribute the numerator. We're going to get 27 plus 9 square root 3 all over. And then if you see that we actually have a denominator whose product ends up looking like a difference of two squares almost, a plus b times the quantity a minus b, and we know that the middle terms are going to cancel out. So the radical, we know that when we multiply these products, the radical is going to cancel out. So when we multiply 3 times 3, we're going to get 9. We multiply 3 times square root of 3, we're going to get plus 3 root 3. 3 times negative root 3 is minus 3 root 3. And then the square root of 3 times the square root of 3, this is minus the square root of 9. And then we're going to simplify that. So our numerator becomes 27 plus 9 square root 3 all over. Now remember that the square root of 9 is 3 here. So we have, like terms, 9 minus 3, which is, well, I'll simplify that in a minute. So, but plus square root of 3 minus square root of 3 cancels out, and I'm left with the square root of 9, which is 3. So this simplifies to 27 plus 9 root 3 all over 6, and then I can reduce this even more. But remember, you only could reduce these terms if you can reduce all 3 terms together. If you only can reduce 2 of them out of the 3, you can't do any of them. Okay, so if you look, they're all divisible by 3, a factor of 3. So if I reduce that, this goes to 3, this goes to 2, this goes to 9. So my final answer is 9 plus 3 square root of 3 all over 2. And that's as far as we can go. Okay. And for problem H, our denominator is x plus the square root of 24. So because we have two terms, we want to multiply the numerator and denominator by the conjugate of x plus square root of 24, which is x minus the square root of 24. And you're going to multiply numerator by that as well. So if we were to rewrite this, we would get the square root of 3 times the quantity x minus the square root of 24 all over x plus the square root of 24 times the quantity x minus the square root of 24. Now again, if we go ahead and distribute our numerator, we're going to get x times the square root of 3, which is x root 3, minus the square root of 3 times the square root of 24 is the square root of 72, which we will go ahead and simplify that later. And then all over, again, if we FOIL our denominator here, we're going to get x times x, which is x squared. X times negative square root of 24 is minus x squared of 24 plus x squared of 24. And then the square root of 24 times the square root of 24 is, we get minus 24. Okay. So upstairs in our numerator, we have x square root 3 minus the square root of 72 can be factored. and reduced. If you look for two products such that one of them is a perfect square, we're going to get 36 times 2. So we have square root of 72 is the square root of 36 times 2, which the square root of 36 is 6, so we're going to get 6 root 2 here. That's what we get for the square root of 72. All over. Now if you look, we have like terms and they just cancel each other out. So we're going to be left with x squared minus 24. And that's as far as we can go. So this is our final answer. Okay. For I, we have 3 plus the square root of 2 times, or divided by 6 minus the square root of 2. So if we multiply by the conjugate of the denominator, we're going to multiply by 6 plus the square root of 2. And again, what you do to the bottom, the denominator, you have to do the numerator as well. Okay. So in this case, this is thought of as one full quantity. So we're really going to do 3 times 6 and distribute that, which is 18, times plus 3 times square root of 2, which is 3 root 2, and then plus 6 times the square root of 2, which is 6 root 2, and then plus square root of 2 times the square root of 2 is the square root of 4, which is just 2. All right, in our denominator, if we were to go ahead and FOIL that, 6 times 6 is 36. 6 times square root of 2 is 6 square root of 2. Negative square root of 2 times 6 is negative 6 root 2. And then negative square root of 2 times positive square root of 2 is just negative 2. Okay. So in our numerator, we can combine like terms. We actually have 18 plus 2, which is 20. And then we have 3 root 2 plus 6 root 2, which is plus 9 root 2. And then our denominator, you can see that the 6 root 2's, positive and negatives cancel out. So we are left with 34. Now in this case, remember, in order for us to reduce, we have to be able to reduce with all 3 terms here. Okay? The binomial on the top and the binomial on the bottom. And unfortunately, no factor goes into all 3. So this is our final answer. Okay? All right. If you look at problem 2, you will see that we have this radical sign of a 3/8 plus 2 over root 2. What we want to do, remember, is separate that and rewrite it as 2 radicals. So the square root of 3/8 is really equal to the square root of 3 divided by the square root of 8 plus 2 over root 2. Now, whenever possible, we know that the square root of 8 can actually be simplified. So whenever possible, simplify any radicals that you have. So the square root of 8, we know, is equivalent to square root of 4 times 2. And the square root of 4 is 2. And then we have root 2 left underneath there. So really, the square root of 3 over square root of 8 is really root 3 over 2 root 2. And then plus 2 over root 2. Now, just like any other fraction, whenever you're adding fractions, you have to have the same denominator. And since 2 root 2 is not the same as root 2, we have to make those denominators the same. So we're going to multiply this denominator by 2 because we're missing that 2 root 2 there. So if we multiply top and bottom by 2, that means we're going to get root 3 plus 4 all over 2 root 2. Okay? So from this point, so it could be rewritten if you want. It doesn't matter if you want to rewrite that as 4 plus the square root of 3 over 2 root 2. But the fact still is that we can't leave the radical in the denominator. We still have to rationalize from this point. So to rationalize this, we're going to multiply top and bottom by square root of 2. So when we go ahead and do that, we're going to actually get square root of 2 times the quantity 4 plus root 3 all over 2 square root of 4, which we will do in a second. So if I go ahead and multiply this, I'm going to get 4 root 2 plus, now root 2 times root 3, remember, is root 6, all over 2 root 4. Now the square root of 4 is 2, so we could just do 2 times 2, which is 4 here. So why don't we make this 4 right now? Oops. Okay. Now again, if you look, there really technically is a 1 there, and because we cannot reduce all 3 terms, we're actually going to leave that. So that is our final answer for that problem. Okay. Now our last problem is number 3. They want us to rationalize the numerator. Rationalizing the numerator. Oh wait, hold on. Pause it, your video.
Please exit the building or head to a location with a coach for practice. Again, that was a 320 bell. Please exit the building or head to a location with your coach. Thank you.
Was there a pause button? All right, so sorry, there was announcements. So when you're rationalizing the numerator, it's the same thing as rationalizing the denominator, but instead you're doing it